Course 1 in Lesson 98, we are adding up the total measure of the angles in two different geometric figures. Three-sided figures, triangles, and four-sided figures, quadrilaterals. Remember, we can talk about a line as 180 degrees, okay, either direction. And so if I split that line up into two angles, add up the total measure of these angles, they're still 180 degrees, which is to say that the interior, because it's inside of the shape, that angle is going to, when added to the exterior angle, equal 180. So if I can learn what the measure of 1 is, I can then determine what 2 is using subtraction, right? And in Lesson 90, we learned about turns and what those measures are. A full turn is 360 degrees. If I'm facing this way and I turn around until I'm facing that way again, that's 360. All the way around is 180 is halfway. So let's imagine Elizabeth makes 4 turns to get around a park. They're trying to show here that going around even a triangular park where you make 3 turns is 360 degrees to get all the way around. And let's say the park is shaped like this, it's still 360 degrees to get around this park because you're going around it. And no matter how you do that, it's 360 degrees. If Elizabeth makes 3 turns, like with the triangle, each turn averages 120 degrees. Less turns means each turn needs to take more degrees. Now remember that. 3 turns, 120. 4 turns are on the second quadrilateral park, means each turn will take a little bit less. 90 degrees per turn. Not each one was a perfect 90. This is an average. We don't know exactly how many each one was, but we'll want to know the average so that we can use it for totals later. Recall that these turns correspond to exterior angles of the polygon, and that exterior and interior angles are supplementary, meaning that they add up to a straight line. Since the exterior angles of the triangle average 120 degrees, the interior angles must average 60 degrees, because if each one is on average 120, and on average they always need to total up to 180, then that means and this was the exteriors that we talked about going around, then inside the interior has to average the extra part, 60 degrees. You're going more degrees on the outside, so you're going less than the quadrilateral on the inside. Versus the quadrilateral, we averaged on the outside what was it? 90 degrees. 90 degrees on each turn. I guess the best way to illustrate that is if I go like this and I made it a straight line, what would this be? This would still be 100. This would be 90 right here, and this would be 90 right here. So if I did that all the way around, you're going to see that these each average 90, which means the interior angle is going to be the same average, because they need to add up to 180 to make a straight line like this one. Now we can talk about the sum of interior angles. We've just proven why. The sum of the interior angles then will be 180. Maybe not all of them are equiangular, but they average up that way. So we can always say a triangle, if you don't even follow what I went through, you can at least say that a triangle is always going to have a total of 180 degrees if you add up all its angles. No matter what each one is, you'll add them to get 180. Again, the reason being, if I make these all straight lines, that's going to average to be 120. 120. So this part is going to be 60 on average, and that comes to 180. Interior angles of a quadrilateral are the same as the exterior. Maybe here the exterior is a little bit less, but here the exterior is more. Okay? Sorry, it should go like that. It should go the same pattern each time, like that. Okay, so 360 when four-sided. Okay? That's all you really need to know to get through today's lesson. Notice when they talk about the measure of an angle, they go M of A, angle A. Okay? And then they label triangle ABC. The measures add up to 180, so how could I find the missing angle? It's a missing number problem. If 60 plus 70 plus missing number is 180, we learned, add up the 130 that you know, this amount is going to be 180 minus 130. Missing number problem. Okay? What's the measure of angle T in quadrilateral QRST? Notice there's no like drawing to label quadrilateral. They just said quadrilateral. 360 always, even if we don't know what each one is individually. So if you know 80 and 80, what's the other one? 110 and, even though it doesn't really look like it, I guess that's a right angle, 90 degrees, because it needs to add up to 360, because it's a quadrilateral. In the lesson practice, they've got a transversal there, a diagonal connecting A and C there. But all you need to do is tell me what's the sum of the measures, angles 1, 2, and 3, and then 4, 5, and 6. They look very similar. Notice what shape you create when you draw a diagonal through opposite corners of a rectangle. You can pretty quickly do all the lesson practice, please, and show those to me.